Okay, ladies and gentlemen, welcome to topic 9. We're going to be looking at solving for inequalities during this topic. Going to find that it's very similar to solving regular equations. It's just a few little rules that we have to keep track of. So we have a superstar who challenges the track team's top 3 runners to beat his time at the 100 meters. You can take 5 seconds from your times and still not best it, he says. The 2 runners fail, but 1 runner doesn't. Show the possible times and how you know that they're right. So this is part of your companion page. So go ahead and pull up your companion page at this point and go ahead and answer those questions. As well as remember there's always the reflection piece as well. So go ahead and do that at this moment. Let me see if I can get as much in as I can so that if you don't have your companion page, you are welcome to use this. Okay, welcome back, ladies and gentlemen. So we can see that 1 runner is running the 100 meters in 15 seconds, but that's not going to be fast enough because 15 seconds minus 5 is 10 seconds, and 10 seconds is still greater than 9.95 seconds. The runner 2 is going to run it in 16 seconds, but he fails. 16 minus 5 equals 11. 11 seconds is still greater than 9.95 seconds. However, runner 3 comes in at 14.5 seconds, and he succeeds at beating the record because 14.5 minus 5 equals 9.5 seconds. Sorry, I'm yawning. 9.5 seconds is in fact less than 9.95. Now maybe you picked very different numbers, but that's all right as long as you picked any 2 that would be greater than 9.95 seconds, and you could have picked something that would have been bigger than 9.952 or 9.96 because those would all have been greater. So your numbers may vary a little bit. The idea was you got 1 that was less and 2 that were greater. And then this is a sample. Remember that this can be different in any way, but basically it's just saying that in order to beat his time, you had to have at least 14.95 seconds, and minusing 5 seconds, you would still beat his record. So this is just one example, but you can take that decimal place as far as you would like. The number of times would be infinite. Okay, ladies and gentlemen, this is some notes that you need to take. We're talking about inequalities in a mathematical sentence that uses the less than equal, greater than equal, or the not equal to symbols. Oops, that's not the button I wanted to hit. Let me try to get a highlighter for us so that we can see it a little bit better. I'm going to go for the green. So if we look at that, we see that these are the symbols that we can use. Over here, we have the symbols broken down for you. That we have a less than equal, greater than equal, and equal not. No, sorry, not to equal to. Make sure you get these copied down in your notes. This is the key essential information that will be very helpful. Okay, so ladies and gentlemen, here's some more information that we need to get down. We're going to be talking about a solution of an inequality is any value of a variable that makes the inequality true. So remember, we're wanting to make sure we have a true statement. Let me see if I can, this time I'll go for yellow. So we're looking to make a inequality a true statement. You can use a number line graph to indicate all the solutions of the inequality with one variable. Hopefully you remember using the number line graph where we represented inequalities earlier in the year. The solution of an inequality is x less than 3, where all numbers are less than 3. So I come down here. Sorry, I'm yawning. It's kind of late. And I have an open circle. The open circle means it is up to but not including 3. Basically, it means it's either a less than sign or a greater than sign. And that's when you will see that we're using an open circle. It's just for this. So that gets an open circle. So we have an open circle, and because all of our numbers are less than, we want to head to the left. So we have all of these values would be less than 3. So we have a true statement. Okay, so ladies and gentlemen, I want you to notice that we've changed the problem, and we're looking at x is less than or equal. When you see an arrow and it has a line under it, it means it is either less than and equal or greater than and equal. And anytime you see that, you're going to have a solid circle on that, or a solid dot. Solid dot or circle, if you want to call it. So if you'll see, we have a solid because that means 3 is included in our answer. It's allowed to be equal to 3, and anything less than 3 is also a part of that answer set. That would make this statement a true statement. Make sure that you're pausing and getting all these notes as we go. Thank you. Okay, so ladies and gentlemen, here's an example. We have 3 statements that have the same solution. We need to cross out the one statement that has a different solution. So a number n is no more than 25. So we know that that means n is not more, so it's going to be less than 25. Then we look at a number n is at most 25. At most. That means it's still going to be less than, but it does say it can be 25 because at most that's what the highest it could be. And then you will work fewer than 25 hours this week. So the number of hours you work is going to be less than 25, but you can make a prediction which one doesn't fit. Now let's just double check. N is a legal speed to travel in a 25-mile-an-hour zone. N is a legal speed to travel in a 25-mile-an-hour zone. So I'm allowed to travel anything less, but I'm also allowed to travel at 25 miles an hour. Now wait, one of these needs to be eliminated. Apparently, I've read something wrong. Let's go back to the top. A number n is no more than 25. It says more than, but it doesn't say it can't be. So up close and careful reading. So which one doesn't belong? This one, where it's only an less than. So these 3 can either be less than or equal to. So now we figured that out. Okay, so this is our example continued. We have 3 statements that have the same solution. We're going to cross out the one with a different solution. So again, we're going to do some careful reading, hopefully a little more careful this time for me. The cost for internet starts at $30 a month. So the cost starts at $30 a month. So the cheapest it could be is $30. So C is going to be, C is greater than 30, and it starts at, so we have an equal, because it could actually be $30. You traveled more than 30 miles yesterday. So we have some number, and I'm still just going to use C so that we keep that the same, because we're just looking for greater than, less than, that kind of thing. You traveled more than 30 miles, so we traveled more than, it means over 30. It might be 30.1, but that's still over 30. Now this one says 30 and everything bigger. Now, what does this dot mean? Go back to your notes. Look, it's open or closed, and they mean different things. This one's closed. It's called solid color. What does that mean? What kind of inequality sign is that going to get? Is it going to get just greater than, or does it get the greater than equal to? I'm serious. Go back to your notes and look. Okay. It is greater and equal. It's solid. It's holding that like the closed fist. So it's holding onto that 30 as well. So yes, it does include that 30. So a number n is at least 30. Well, in this case, I'm just going to change it to a C because that's what I started out with instead of saying n. So a number C is at least 30. At least. So that means what? We know it's at least, so it could be bigger. Could it be the same? Yes, it can. So we just found out which one does not belong. This, because it's simply just a greater than. Excellent job. There is a second part to this video that actually it looks like it might be broken into 3 parts because I don't want to make them too terribly long. So make sure that you watch part 2 and part 3 of the topic 9-1.